Hi guys, these are some notes about the foundations of geometry and just the shapes that we're going to be using to construct all sorts of shapes, but we need to start with the most basic stuff. Our objectives here are to identify, name, and draw points and lines and planes, and then also some segments and rays, and apply basic facts about points, lines, and planes, which we will use to make segments and rays. Okay, the first thing we want to identify is a point. And it names a location, and it has zero size. It has no size. It is represented by a dot. So like this is point P, and I'm going to name it by putting a capital letter next to it. A line is a straight path, and it has no thickness, and it goes on forever. So, and it's a bunch of points all in one line. So I can have 2 points like point A and point B, and I can connect them and keep going in both directions. Okay? The way we name it is 2 different ways. First of all, it could have like a cursive letter next to it, and you could call this line L. Okay? Or you can name it by the points. And the way you say it is you write AB, those are 2 points on it, and you draw the line symbol above it. You can go the other direction. You can say this is line BA and just draw the line symbol above it. Any of those work. All right, a plane is our next figure here that we're going to draw, and it is a flat surface. It has no thickness, and it extends forever. So if I'm going to draw a plane, I'm going to look like I'm kind of looking at it this way here. Now you have to remember it goes on forever. Just like this line, it doesn't stop here and here. The arrows indicate that it keeps going. A plane goes on in every direction, or I'm sorry, it goes on forever on that flat surface there. You can name these 2 different ways, again with a capital letter in cursive, for instance R here, and I would say plane R. Or you can name it by 3 points, point A, point B, and point C, in which case I would say plane ABC. Okay, remember it goes on forever. It does not end at these boundaries. I just have no way to draw it other than with some boundaries. Okay, so let's talk about what happens when you have several points that lie on the same, several points that lie on the same line, and those are called collinear. Co meaning together, and then linear. So points that lie on the same line are collinear. It says draw a figure below that illustrates points KL and M that are collinear, but KL and N are non-collinear. So let's start with the first one. K, L, and M are collinear, so they're all on the same line, but N, K, L, and N are non-collinear, so I need to draw N off over here somewhere. It can't be on the same line as those guys. So if points on the same line are collinear, points that are in the same plane are called coplanar. Okay, that just means they're all on the same plane. All right, so let's look at some of these examples here. Let's use this diagram, and let's find 3 collinear points, so points that are on the same line. And I'm going to choose these 3 here, D, A, and C. Those are collinear, D, A, and C. They're all on the same line. And for coplanar points, how about D, A, C, B? Okay, these 4 points right here, they all are on the same plane. I can't use E. It's not on the same plane. If this thing here was a flat surface, like a piece of paper, D, A, C, and E, for instance, no, that's a bad example. D, B, C, and E, for instance, could not be on the same plane. And then last 3 non-collinear points. How about D, C, and then E? D and C are collinear, but E is not collinear with them. Okay? All right, let's look at some secondary shapes we can create. It says a blank is part of a line consisting of 2 points and all the points in between them. That is a segment. And it's different than a line. If you remember up here for our line, I had line L, which had points A and B on it, and it goes in both directions on forever. A segment ends at the 2 points. So for instance, if I have segment EF, it stops at E and it stops at F. It doesn't go forever. And the way we name it is we say E and F, but we just draw a segment symbol above it, not a line symbol. There's no arrows. Again, I could name it FE instead if I wanted to go the other direction. Okay. What we call these points E and F are endpoints. So it says an endpoint is a point at one end of a segment or the starting point of a ray. We'll talk about a ray here in a second. So in this case here, let me draw another version. Let's put it C and D. C and D are endpoints. Okay. If you had another point in between, point E in between, E would not be an endpoint. All right. Next we have a ray. I said a moment ago we talked about them. A ray is part of a line. It starts at an endpoint and goes forever in one direction. So for instance, let's have point A and point B. We're going to have it start at A and go towards B forever. And the way we would name that is AB, and we put the ray symbol above it. Now what's interesting here is I can't say ray BA going the other direction. This is specifically, you have to be more specific in how you name it. You have to name the end point first and then the direction it goes. And then lastly, you can have opposite rays. Are two rays that have common endpoint and form a line. So let's have this starting point here of A, and let's have a ray that goes this direction, B. Okay, so we have ray AB, and then let's have a ray that goes this direction, F. A, F. Those guys are opposite rays. Starting with A going towards B is one ray. Starting with A and going towards F is another ray. Spell opposite. There we go. Sorry. Okay. All right, now we've got some activities for you on the back. Draw and label each of the following. A segment with endpoints MN. Okay, so remember what a segment is. It's not a full line. It has a starting point and an ending point, and one of them is named M, the other is named N. Next, opposite rays with common endpoint T. So here's T, and I'm going to go this direction, and I don't know, call that X. Go this direction and call this, and it doesn't matter, W. And so TX is one ray, and TW is my other ray. T going towards X and T going towards W. Okay. It looks like my diagram did not come out on this document. So here's what it should look like. I'll make sure this comes out on your document. Here's what this should look like here. Sorry about that. Just realized it. It says name the intersection of line M. Here's line M and plane R. And here's R. So where is M going through plane R? Now this you have to use your imagination a little bit. You can see that this is dotted. This line goes through right here, and it's dotted because in theory you wouldn't be able to see through it. If this was solid, this would be behind it. Okay, so it looks like point Z is the intersection. Okay, it says name two lines in plane R that intersect line M. So the lines have to be in plane R, and they have to intersect line M. So looks like line XZ intersects at line M, and it looks like line YZ intersects line M. So line XZ and line YZ. Okay, so here's line M, and those two lines intersect it. It says name a line in plane R that does not intersect line M. Well, if this is line M, it doesn't look like this is going to intersect it ever. Because remember, this is kind of angled this way, this is going straight across this way, those would never touch. So it looks like line XY would not intersect. Okay. Name 3 coplanar points. So we need 3 points that are all in the same plane. So that's anything that exists on plane R. Okay, remember this is sticking up. It's like coming through it at a funny angle. So point W is actually kind of behind. If this was a sheet of paper, it'd be behind it. So how about points X, Y, and Z? Okay. And 3 non-coplanar points. So we need to name a point that does not exist on plane R. Okay. So how about X and Y, but how about W? It's behind that piece of paper. Those are non-coplanar. All right. Oh, we're missing another diagram. Okay. All right, so these are what are called postulates, and these are rules or truths, or you can think of them kind of like definitions, but they're things that are always true, and we're talking specifically about points, lines, and planes here. It is not important that you learn these numbers, okay? But these are truths about points, lines, and planes. It says through any 2 points there is exactly 1 line, and that makes sense. If you have 2 points, for instance, T and Z up here, you could not draw any other line other than this line that's drawn here. Like you can't go any other angle and get through both of those with a straight line. That makes sense. It says through any 3 non-collinear points, there is exactly 1 plane containing them. Okay, which makes sense. So if you have 3 points out there that are non-collinear, they're not in a straight line, there's think of it, 1 sheet of paper that could contain all 3 of those points. Okay, if it's something that's flat, you couldn't go through all 3 of them. All right, if 2 points lie in a plane, then the line containing those points lies in the plane. Okay, so if 2 points are in a plane, let's think about this. Here's 2 points, and they're on this plane. The line that contains those is also in that plane. That makes sense. All right, here we go. We're going to sketch some of these. Sketch a figure that shows a line that lies in a plane. So here's a plane. Remember how we draw it, and then you can put any line you want in here. And let's give it letters so that we can name it and name our plane. So line ST lies in plane Q. Good. It says a line intersects a plane but does not lie in the plane. Sorry, my words wrapped around. Okay, so we need to draw a plane. Let's label it plane R. So a line is going to go through it but does not lie in it. So it's not lying on flat on the plane like this. It's going through it. So you need to draw it like it's an arrow going through a piece of paper. So it comes out right here, but then you have to think it goes behind it too. So you make dots, and then down here where you can see it again. And we can label it. We can say, let's give it points A and B. And we can say line AB intersects plane R. All right, let's talk about lines that intersect. If 2 lines intersect, they intersect at exactly 1 point. So for instance, if you have these 2 lines, there's only 1 place that they're going to intersect. They can't intersect twice. It wouldn't be straight lines then. And here I've drawn a sketch right here. There you go. All right, this is a tougher one. If 2 planes intersect, they intersect in exactly 1 line. And this is kind of hard to draw. I think I might have an example here I can show you. So this is 2 planes intersecting. I don't know how well you can see this on this camera. Let's see if I can move the camera a bit. I don't know if it's going to work. Anyway, here are, well, no, I'm sorry, you can't see it. I'll just have to draw it on here. Okay, so let's draw two planes intersecting. So here's one plane, and then let's draw another plane coming through it. Okay, and where they intersect is right here along this line. Okay, so here's one page, one sheet this direction, and one sheet this direction. And you artsy types can probably do a better job. Another way to think of it, it might be easier for you to see, is what about two sides of a box? Okay, here's a plane on this side, and here's a plane on this side, and they intersect right here on this line. Okay, along that line. Another way to think about it. All right, thank you very much.